A talk with no Python, no CSS, no fancy content types or JavaScript. We are talking to integrators and system administrators about solid configurations of your zope and plone sites that will give you better security than you're probably getting right now.
Little bit of Python with the past plugins, but I won't show you any of it.
Yes, right. There's lots behind it. Shell scripts, Python scripts, IP tables, everything, but it's not really what we're talking about. We're talking about the concepts. I'm Steve McMahon. I'm going to be starting us out. I'll then be followed by Eric Rose. Eric and I both spent a lot of time thinking about security of zope and plone setups. I've just been doing it because I'm paranoid. Eric's been doing it as part of the hosting project at WebLion. So we've got a fair amount of experience between us. You may have more experience out there. We're both decent speakers, so feel free to interrupt us or to ask questions with anything short. Save it until the end if it's anything long. Okay? Let's see. Okay, I'm going to be starting out. Again, I'm Steve. What I'm going to be talking about is, first of all, talking about some basic concepts of security, computer security. Then I'm going to go on to talk about daemons and file systems and how they should work together and how you could configure them to get better security. Eric is going to be talking first about ports, protecting your ports, and then is going to move on to authentication. We're going to roughly split it in half. Okay, first of all, just to orient you, I'm going to say something about common vulnerability and exposure records. It's just a database that is very publicly maintained about common exposures for all sorts of systems. And this year, for the very first time, 3 applications have shown up in the top 10 for vulnerabilities. That's brand new. Guess what? They were all 3 PHP applications, but there's now a reason for concern. Web applications are being seriously scrutinized. People are really looking at them about vulnerabilities, and we want to do a good job. So let's take a look at common vulnerabilities and exposures. The records for 3 villains and our hero. Take a look at that. That funny one over there with 3 dots has had only 9 vulnerabilities, none of them serious, and the other 3 aren't looking so good. A lot of those are SQL injection attacks, but some of them are also arbitrary code attacks.
What's the time frame?
That's a year. Oh, actually, that's not a year. This is since the records began to be kept that we're looking at. Andy.
The Pico exploit was serious.
That was serious. Okay, one serious then. Pardon me. I certainly consider it serious, so we'll be talking about it a little bit. So, but you may be wondering, if we've had so few exposed vulnerabilities, why should you be worrying? Why are we bothering to give you this attack? Well, the big reason is 9 is still 9 too many. One of those vulnerabilities was extremely scary. I'll talk about it a little bit. But also, if we're going to maintain a good security record, we really need to do our part. Every system administrator, every integrator needs to be working on security and needs to be conscious of it. Let me talk some about basics about computer security, and please forgive me if you've taken courses on this in the past and I'm recovering old material, but it's worth going over again. Key concept in computer security is defense in depth. This is a little diagram of a nuclear power plant, and the idea is that if containment is ruptured, there is not 1 or 2, but several different layers of defense that are going to occur. This has become sort of a model for computer science. The idea is that rather than relying on just any one protection, you assemble several, and that it is actually much harder to get around several levels of defense than it is to get around one strong one. So that's a key concept, and what Eric and I are really going to be going over today is the layers of that defense in depth. Those layers that are behind your firewall or even behind the application. Now, what is not defense in depth? This is not in defense in depth. Remember, I was showing you the diagram of a nuclear reactor. This is actually a gate outside a nuclear reactor. Can everybody see well enough to see some of the problems here? There's nothing around the gate. It's just a freestanding gate. Also, needless to say, you could take a ladder up to it, or that's a dirt road, you could dig underneath it. So that is not defense in depth. That is just one strong wall. Let me talk about the single wall defense. I'm going to give you a historical example, and my apologies to people who may interpret history differently or pronounce the words differently, but probably the most famous example of a single wall defense is the Maginot Line. This was during prior to World War II. The French and then the Belgians built a very strong defensive line between those countries and Germany. And when I say very strong, it was extremely strong. They had all sorts of strong emplacements and guns to defend it. Now, it's become something of a fable in history that the Germans simply went around the Maginot Line. In fact, they did not go around it. The Maginot Line failed when the Germans attacked it at its strongest point, which was in Belgium. They hit it by pure force, and they destroyed it. And the problem of the Maginot Line was not that it wasn't strong. The problem was that there was nearly nothing behind it. The French and the Belgians were unable to mobilize quickly enough. And again, my apologies to anyone who interprets the history of this period differently. Now, I'm going to offer you a proposition. Zope is our Maginot Line, which is to say Zope is an extremely strong defensive line that we have been relying on. And it does a great job. I don't want to take anything away from it. However, it is inadequate for us to just simply rely on Zope's superb security system. We need to put some defenses behind it if we're really going to have tight sites that are very difficult to penetrate. An example of why that's necessary, Andy had mentioned the pickling bug. At a certain point in time, and I hope all of you patched against this when it came out, we had CVE, Common Vulnerability and Exposure Record 2007-5741. And the scariest words any system administrator ever wants to see would be execute arbitrary Python code via network data. I am not talking about restricted Python. This is arbitrary Python. Anybody who could use this vulnerability, and they could use it just simply by sending a cookie to the system, could use whatever Python they wanted to use. That Python would execute with the privileges that zope and plone was running at. So pretty scary. That has, of course, been patched, but it is a reason why we cannot take for granted Zope's great security record. This was not a Zope problem. We need to have defenses behind it. One of the key ideas behind defense in depth when we get into actual computer science is the principle of least privileges, sometimes called the principle of least authority. And it is the idea that in particular, any long-lived process that is connected to the internet, not just connected to the internet, but especially those connected to the internet, should be running with the least possible privileges. It should have the least possible authority inside your computer, so that if that long-life process, that daemon, gets hacked, it will be able to do very little. In short, this principle is sort of an employees do not have combination to safe defense. You see this all over the place, and it's meant to protect the employees as well as the store. The mechanism by which it's enforced is a safe into which you can make deposits, but short of blowing it up, cannot get in without the combination. And if nobody on the premises has the combination, and if you're depositing in the large bills as you go, it limits the damage that will be done if somebody gets in to rob your retail store. Okay, that's the end of my talk about the basics. Now I'm going to start, let me back up one. No, actually not there. There we go. To begin to talk about something concrete. We refer to those long-lived processes as daemons. And that's the old Berkeley Systems daemon there. A lot of you may recognize it. On Windows, they're called services. They're long-lived processes, and the kinds we're talking about are the ones connected to the internet, like Zope, Apache, the email system. Ideally, we want those systems, daemons and services, to have no rights. No right turn allowed. Of course, that isn't possible. We have to give them some rights or they couldn't do their job, but we want to minimize those rights. Let's look at a very bad example. This has been somewhat fixed, but this is circa 1990s SendMail. Who knows the nickname for SendMail? Paul, something needed?
Just requesting you turn the lights down so we can see your slides a little
Okay,
bit.
just a sec. Let's see if I can manage that. I think this is the switch for that.
I think they're on the wall behind you.
The wall behind me. There are far too many switches there. I'll never figure it out. If somebody else wants to take a shot,
Here I am.
To it. We have Eric on for. Okay. You don't need to be able to read this in detail. What I want you to get out of this is SendMail. Who knows the nickname that SendMail had during this period of time? Anybody? SendMail was called root mail. It was called root mail because it was the most frequent avenue of attack for Unix-like systems during that period of time. There were viruses that hacked over short periods of time thousands and thousands of SendMail systems all over the country. SendMail was running as a nearly unitary program. That's why we have just one circle up here with SendMail in it, and it ran with root privileges. Then it connected to another daemon, the bin mail daemon that actually distributed the mail on the system, also running with root privileges. All somebody had to do was to figure out how to hack one part of SendMail, and they could do anything on a system. They owned it. This, by comparison, our hero, is Postfix, which I hope a lot of you are using as your mail transport agent.
Hooray!
Hooray, hooray for SendMail. Hooray for Postfix. Postfix was created by Vitsi Venema while he was working for IBM. He's gone on to become one of the greatest forensic experts on computers that we have. And QuickMail was going on at about the same time, by the way, with some of the same concepts. A very big concept in it was modularity. You had a variety of worker processes, all of which did very well-defined things and communicated with one another in a very tightly defined fashion and ran with very low privileges. All of the green parts that you're seeing up there are parts of Postfix. The red parts are basically part of Unix that SendMail has to communicate with. But by the time you get to those parts, you've gone through several layers at which minimally privileged parts of Postfix are sending well-structured packets between one another and just throwing away any packets that don't make sense any longer. Postfix has an essentially unmarred security record. That's what we should aim for. That doesn't mean there's never been a bug, but as far as I know, nobody's ever used Postfix in order to own a server. How are we going to implement that sort of security in zope and plone? I'm going to jump right into the file and process level, talk about how we want to configure the daemons. Here's what I think is a typical installation of zope right now, zope and plone. We have a process, the zope plone process, that is typically running with a zope or plone ID, and then it owns a whole bunch of files that are owned by plone itself. That includes the var directory, which is to say the database. It includes the logs, and it includes all of the parts and all of the .pyc files, the compiled Python files. I'll bet perhaps the majority of you out there have this sort of configuration where the plone or zope daemon actually owns all of its associated files, including its own program files. So why is that so bad? Because the daemon can write into its own code space. That means that if somebody manages to penetrate the system, for example, by the pickle vulnerability we talked about earlier, they will be able to write files into the system that will then be executed later on by the program. They may not be executed by a server running at the root level, but they'll be able to do things like get at the administrative passwords. They'll be able to write other programs onto the disk. They might replace the startup routine, and thus when root then executes the startup routine later on, they own your system. It's not adequate security. Let's look at a better way of setting this up. We have a bit of a division here. We still have just one process, and it's running under the plone ID. It still owns the database and the log files. Hard to get around that, though I'll show you that in a bit. But in this case, we have root or some other completely distinct owner owning the whole of the parts directory and all of the Python and compiled Python files. And in this case, if somebody should manage to subvert the plone daemon, they might be able to trash your log files. They might be able to trash the zope database and get all of the information on that. But it's much less likely that they're going to come to own your system as a result. Paul, did you have a question?
It seems like root is a risky choice here. Why not use some less privileged user?
You could use a less privileged user. The key is that it be a different user. And I don't think it's necessarily bad for root to do that, because it's not as if we're executing programs under the root identity. It's just that root is owning the files.
So the permissions on those files are...
Root owns them. The daemon needs to be able to read them so that it can read its Python and read its compiled Python files. So why has this been happening for so long? Why have we been doing it this way? Well, one of the reasons is that when you crank up zope, it compiles all the Python files at that moment, including all the plone files. Now, the zope installation is smart enough that it compiles all of its Python files. It writes out the PYC files when it's installed. Plone has not been that smart. Plone is simply putting the Python files on, and then the compiled files got created. And so it became, I think, commonplace among zope plone administrators to give the plone or zope process identity the right to write into the code space. We can avoid it. One way to avoid it is, as the identity that owns all your code files, you run Python's compile all. Compile all will go through and create all those PYC files, and then you're creating them as root or as some other distinct identity. Another much easier way, if you're using build-out, is that you can simply add a precompile part to your build-out, saying recipe equals plone recipe precompiler, and it will go through, and when you run build-out, which you should be doing with a distinct identity that's not the same one as the daemon, it will create all of those files. That allows you to create very distinct spaces. Yes, Tom?
Is the order in which I include the precompiled part, does it have to be at the very beginning? Or
No, it can be anywhere. It's not really going to matter. Also, I as a routine thing, use plone recipe command to put in a few commands to make sure that they run through and set all the permissions. All of that's actually in the unified installer right now through this 3.1 generation. So if you've been using the 3.1 generation unified installer, you've been getting this. Let's talk about an even better way to do it, and that is to use Zio. Zio allows us to split apart the client and the server. So we can have a process that might be, say, running as Zio. That process is the only one that has to touch the zope database. So it can write into it. It's going to need to be able to read the parts directory, but it doesn't need to be able to write into it. The clients we have running as a separate user identity. Maybe Z client, maybe plone, whatever you want to use. They need to be able to write out their own log files. They need to be able to read the parts directory, but they don't really need to be able to do anything else. Then the two communicate between one another with well-defined packets, which is to say calls from the Z client to get the data out of the database, and that's their only communication. So it's not exactly postfix, but here we've achieved multiple worker processes, each one running with the practical limitation of their privileges. A much better setup, I think. The unified installer that we're going to be coming out with the 3.2 series and the experimental ones that we've got out right now achieve this layout when you do it, when you run them to set up a Zio server. And if you don't want to use the unified installer, which is absolutely fine, you can still study what's set up in there to see how it does it, to see how it achieves this division. You can do this under Windows. Any number of Windows administrators are essentially running the plone service under exactly the same owner identity as the one that owns all the files. It's not a good practice. Instead, you can set an owner identity for those files, and you can set who owns the database and set who owns the code and make them different. And then you go to your services applet where you set it up and you set a separate identity to run the service. That service will need to be able to write the database and its log files, but it should not be able to write into the code space. Okay.
Don't press that button.
There we go. Okay, that's the end of files and processes. That's the end of implementation, and that's the end of my part.
Thanks a lot, Steve. The moral to learn here is that when you put a keynote in rehearsal mode, it does not do dual display stuff. So when you want to present, you have to be sure to choose present. So learn from my mistakes. Okay. Thanks, Steve. So now that we're done talking about file and process type stuff, I'm going to talk about port security. And by that I mean securing paths of communication all the way from the user's browser straight down to Zope. Now, in a naive installation of Zope, you have it directly exposed to the evil monstrous internet. People can go directly to it, which means they can send malformed HTTP requests directly to it. And Zope doesn't handle this very well. You might even be able to exploit it using that. So what you do is you put a nice web server between them. Something like Apache that can deal with those, it can deal with the viruses. It's also a performance boost because Zope doesn't have to waste its precious cycles on them. So requests start out here, go over there, and the responses go down the other way. Also, when you use a web server, you have the opportunity to use SSL, which Zope doesn't handle on its own. Now, SSL, for those of you who don't know, which probably aren't many, is a way of encrypting stuff that starts off with the user, goes that way, and then the response is sent back encrypted. That includes things like usernames, passwords, and sensitive cookies. If you're not using SSL, you can use something like Session Crumbler to mitigate the problem, but still, that cookie is hijackable. You can have your session hijacked if someone sniffs it, and the first request has to carry an unencrypted username and password, so that's just as bad if someone's on the wire there. I don't let anybody log in without using SSL myself. Now, in this kind of setup, the internet can still get to Zope on port 8080 if they connect out via that port. What we'd like to do is have Zope listen on the local machine only, not even listen to the big internet at large, just listen to the server that Apache is running on. So we can do that with one line in zope.conf, just IP address 127.0.0.1, and then that problem goes away. Incidentally, I like to not even bother mapping the root of the ZMI through Apache. There's no reason you need to expose that. In fact, this is part of the defense in depth thing. We can add a second layer, which is SSH tunneling into the machine in order to access the root of the ZMI. I make all my admins run this command. It works on any machine that has SSH, and it works to any server running SSH daemon. What this means is that if you go to your browser on your local laptop, 127.0.0.1:3333, what you'll get is a response as if you were talking directly to the Zope on the server, except that it's passed over a secure channel. Now the depth comes in where you can, have SSH do tar pitting. For example, if they log in once and get it wrong, they got to wait 5 seconds to log in again. The next time they got to wait 10 seconds. That makes you less vulnerable to dictionary attacks on your admin passwords. And if you're using Windows, WinSSH does this like a champ. Now if you're using Zio, which you should be all the time, and especially for production, you have to make sure that it's not exposed to the big bad internet as well. Same sort of thing. And it's got the same sort of solution. One line in zio.conf, and that problem goes away too. Now you have yourself a nice, defensible, linear information flow with everything talking to only one other thing on each side. Of course, this assumes that everything's running on the same machine, all this local socket stuff. Otherwise, don't do what I said. If you're running it on multiple servers, Zio on one, Zope on another, then you need to adjust your inter-machine firewalls. So what if you have untrusted people, non-root type people, on your server for one reason or another? These people should not be talking to Zio. They should not be talking to Zope directly because those things are very trusting. If you're on Linux, you're in luck because you can rig IP tables to do UID-based packet filtering. Isn't that cool? You can have it so that only Apache gets to talk to Zope directly, and only Zope gets to talk to Zio directly. Here's the first IP tables rule. All this means is take a look at that D port 81 there. That means anything headed to port 81. We're going to take a look at the owner. We're going to make sure it's www data. In other words, make sure it came from Apache. And if that ain't true, we're going to reject it, drop it on the floor. We can do the same thing for Zio. If it's headed to 8100, that is Zope, and it ain't owned by Zope, we drop it on the floor and reject it. With these two rules set up, you can still have your non-root people log into your server and edit their static HTML or whatever it is they do without worrying about them sending rogue requests to Zio and deleting all your data or setting your admin passwords or something like that. These two paths go away. I should also mention that Zio is capable of accepting password authentication. I haven't played with it much, but the password's probably going to end up in zope.conf, so if you do that route, make sure that your permissions on zope.conf are tightened down. Privileged ports. You might have noticed I've been using kind of a funny port for Zope in the earlier slides. I've been using 81 instead of 8080. This has some security implications. Let me tell you a story. Once upon a time, on a faraway server, ruled a fair young Zope instance. It served up requests and sucked up all the kingdom's RAM, and all was well. Then one day, the Zope instance crashed. Now, the evil sorcerer, who had been in charge of maintaining the Palace's legacy system, saw his chance. He immediately started up his own Zope instance, which looked just like the one that had crashed. He painted it the same, it was on the same port and everything. And since he put it in the same place and made it look the same, nobody noticed any difference. And they kept right on typing their usernames and passwords into it like before. Now, of course, the sorcerer had his zope instance mail him everybody's password, and he soon staged a palace coup and forced everyone to switch to intercal. Moral of this: make sure you run all your services on ports that are less than 1024. That's privileged ports in Unix speak, because non-root people can't listen on those ports. So that keeps your evil dudes out of your stuff. This is really simple to do with zope.conf. You can just tell it, hey, listen on such and such a port. But Zio, it's trickier. In fact, I haven't been able to get it to work because Zio drops its privileges too soon. You run Zio as root, first it drops its privileges, and then it tries to open the port, and that doesn't go so well if that's a privileged port. So if you know how to get this to work, teach me during the Q&A. And B, try running Zio on a Unix socket. You can actually get it to work on a file system socket, and that way you don't need to do anything with IP tables as far as Zio goes, and you can control the whole thing with file system permissions.
Is this compatible with running as a zope user or a plone user?
Absolutely. You'd probably make the socket owned by Zope, make it writable by Zope, and then the Zopes could ask stuff to the Zio. So now that we're done with communication security, we're going to talk about security within the application layer, within Zope itself. Plone comes with a fancy schmancy inversion of control framework for authorization and authentication called Pluggable Auth Service, or PASS. And if you look over here, these blue suckers, these are all the hook points that PASS exposes. You can customize all of those by writing a plugin or taking someone else's. For example, you could write yourself or steal yourself a challenge plugin, and that's how you customize how users are prompted for credentials. For example, you could replace it with, I don't know, something hashed or Kerberos or a retinal scan, depending on what your user's stuff supports. Or you could write a properties plugin, which is a common one, and have it pull full names or hat colors out of LDAP. One thing that I like to do with PASS is delegate authentication to Apache, because Apache has a big pile of authentication modules that are well maintained by somebody else that I don't have to think about. You got auth curb, Kerberos stuff, you got cosign, pub cookie, and shibboleth, and LDAP, and the list goes on and on. So if you have Apache deal with that, you can just have it pass the logged in name, once it's checked them out, to Zope, and make Zope believe them. I wrote a PASS plugin to do just this. It's called, aptly enough, Web Server Auth. This is kind of take two of this approach. There was an older couple of products called Apache Pass, and then there's another little shim that I wrote called Auto Member Maker. And I ended up maintaining both of those things. And there's so much legacy in them, I finally decided it was time to get a clean start, shake off the legacy, and improve the UI for both integrators and for the end users. So if you're going to do this today, I say Apache Pass and Auto Member Maker are dead as of this moment. Use Web Server Auth. Web Server Auth does a couple of things. First of all, when an anonymous user tries to get at something that he doesn't have privileges for, it redirects him to the HTTPS version of the page he's looking at. Then you configure your web server to always ask for authentication on the HTTPS side. And I'll show you how to do that in a moment. Number two, we make Zope believe the username that Apache sends in a request header. And number three, it has a terrible little cheat that makes PASS validate users who can't be enumerated. Incidentally, this terrible little stack-sniffing cheat, it's the same thing that OpenID does, the OpenID plugin which ships with Plone, and Wiggy wrote that, so he also wrote the framework, so you should feel a little better about that. So, how do you make Apache do the stuff that Web Server Auth expects? This is in Web Server Auth's README in more depth, so you can go there if you have more depthy kind of questions, but I'll brush past it quickly to give you an idea. First of all, you need to make sure that when you're getting a page from HTTPS, Apache or whatever your web server is prompts you for auth. Here's how to do it in Apache. Virtual host 443, that's this SSL port, location /, so I'm mapping this whole thing to the Plone instance. I set up just basic file-based password asking, but you can replace that with Kerberos or whatever auth directives you like. Then the operative line is the last one, require valid user. That means no matter what, we're asking for a password here. We're making sure this guy is who he thinks he is. Second thing you need to make it do is pass the username, once it's been authenticated, to Zope in a request header. You need to read this kind of from the bottom to the top. Down here is your typical virtual host monster reverse proxying thing that you have anytime you put a web server in front of Plone. The new part is this E = remote user thing at the bottom line. What that does is takes the username that's been authenticated by the auth stack, the capital remote user thing, and put it into the remote user lowercase thing, which is a Apache environment variable. Then you go back up here, where it takes that lowercase remote user and then shoves it in a request header so that Zope can see it. It ends up in the HTTP X remote user header. And then web server auth knows how to make Zope believe that. So that's pretty short. Most of this is comments, and that's all you need to do to get Apache to work with web server auth. Except that if you're running also stuff on port 80, make darn sure you unset that header, you clear that out, because otherwise end users can go ahead and use your Firefox extensions or just type into a telnet window and send their own HTTP X remote user header and masquerade as anybody they want. So don't miss that. That's in the README. I want to re-emphasize that you need to have Zope inaccessible from the outside if you're doing this. Otherwise, people can do this same sort of trick, and Zope will believe them. Another popular thing to do with PASS is integrate with LDAP. This way you can set your group memberships in one place, your user attributes, and you can use them in Plone, you can use them in Drupal, or whatever else you happen to have that has an LDAP kind of adapter. The best integration story for this at the moment is a stack of two products, plone LDAP and plone.app.ldap. That used to be called Simplon. Now, the first product provides the mechanics and the UI, and a ZMI-based UI, and plone.app.ldap gives you a really nice in-Plone UI for it. With these two products, you can put your users and groups in LDAP, you can create and delete them through Plone, and you can totally relax because the same dude who wrote PASS wrote these products. Now, this LDAP stuff and web server auth are two flavors that go great together. You use web server auth to get them logged in, and then once you know who they are, you use plone LDAP and plone.app.ldap and grant them whatever privileges you want and get their hat colors and full names and all that jazz. You hit kind of this sweet spot that I use at my Penn State's campus, where you have web server auth integrate with your single sign-on system, and then you grab all your enterprise data and use that once they're in. If you don't like these, or if you don't like the other ones you can pull off the shelf, you can write your own. It's not too bad. There are a couple references to help you with this. There's a great user manual that Wiggy, the author, wrote. That's a good way to get an overview of the framework. There is the simplest PASS plugin in the world called No-Go Challenger. There is, if you go up a level from that in the collective, you'll find a whole folder full of various PASS plugins, many of which are good examples. And then my favorite place is within Pluggable Auth Service itself. You can look at the interfaces folder, and there's the official documentation for each of those blue hook points that I showed. Finally, I'll mention there's a paster template for this. It's called Plone PASS, and I'm ambivalent about it. It doesn't generate PEP 8 compliant code, but at least it doesn't generate much of it. I personally like to start from something like No-Go Challenger and customize, but I hear, I haven't tried this, that if you generate your template like your skeleton like that, and then CD into that, and then run paster again, I think you get some more options. And it says, hey, you want to tack a challenge onto this? You want to tack a properties plugin onto this? I don't know, but something to look at. I guess that's the end. So we're going to open up for questions here. And Steve, you want to stand up and join me? Sure.
How does a WSGI stack apply to the PASS plugins and all?
Well, that's a good question. I would say you have a lot of choices. You can say you're using a Deliverance as a WSGI plugin, for example. You can still do all your PASS at the Zope layer. I don't know of anybody running PASS plugins as WSGI middleware. I don't know if anybody's rigged that to work yet.
Yes.
But you can certainly do your auth as a WSGI plugin and then do something like what I did with Apache. Stick it in a header someplace and tell Zope to believe it. You could probably even use web server auth to do the believing.
Rob Miller to the rescue.
WSGI actually has, WSGI passes a dictionary, an environment dictionary, through its pipeline, and that's trustable because all WSGI processing, a whole WSGI pipeline is a single process. So you can have an auth piece of middleware at the beginning of the stack that sets the remote user value in that environment, and then you can have a pass plugin that honors that.
Sounds
You
great.
don't have to worry about trusting it in the same way that you do, or cleaning the header, because inside that pipeline it's all trusted.
It doesn't happen to look the same as a Apache set environment variable, does it? Or response header, or request header, I mean?
It's similar, but it's very analogous to an HTTP header set.
But I have to change the
HTTP
code.
Headers are in there, but it's a little different.
Okay.
And I think it might already have been done, actually. I think some people might be doing it with propose.who as the auth middleware. I couldn't swear to that.
Good, it should be done. On the left here.
Have you worked at SE-Linux settings for additional security?
I haven't. How about you, Steve?
No, I haven't. I mean, it would be great. I'm sure there'd be some little problems to solve. It would be a great project to work on.
I'm one of those terrible people who shuts it off the first thing because it drives them crazy.
Is there tar pitting functionality built into Plone's logon form?
No.
Could you repeat the question?
Is there tar pitting functionality built into Plone's login form?
Or add-on?
In fact, I don't know of any plugin that implements that at all, but it would be perfectly possible.
And for those, there may be some people who don't recognize the term tar pit. I mean, in this case, what it would mean is that if you failed to authenticate, that there would be some delay before you could authenticate again, so that somebody cannot run 1,000 requests a second against your server to try and crack your passwords.
Any others? In the front.
I don't think the logging actually happens. Like if you try and log in and fail, I don't think there's any error messages in the log file.
That's a drag.
Yeah, it is.
You could certainly do that in a
Is
pass
there
plugin.
planning on that?
I don't know of any plans, but that's a fine idea. And if you're using a pass plugin, that should happen in the challenge handler probably.
We couldn't hear the idea behind here.
I'm sorry, I'm gonna get in this habit. What was your question again?
Just to log.
Right,
Oh.
whether or not failed logins are logged, and
They
as
ain't.
far as we know, they're not. And that would probably be a very easy fix. I mean, that's probably finding one spot in the code and changing the warning level.
Now, if you're using Apache or something to say mud-auth curb, for example, it does do something on failure.
Plone's error log actually has a default set of ignored exceptions that don't get logged, and
Yeah.
unauthorized is one of those. So you can change that in the ZMI.
Well,
Like, if
that's a different thing. We know who you are, but you aren't allowed to see this. And that also happens every time you're anonymous and hit something. So that's probably not terribly useful.
Okay, probably one more question, because we're nearly out of time. Lee?
So what's the current status of the current universal installer 3.1 and versus the 3.2? Because I was a little confused about which scenarios apply to which version.
Okay, the 3.1 series of unified installer, in fact, the whole 3 series uses that first level of security I was talking about. The new experimental installer, which will be mainstream for 3.2, uses different permissions for ZO and ZO clients. So right now it's as tight as I know how to get it, and if anybody's got better ideas, please let me know.
All right. Thanks so much for
Thank you
coming.
all.